Hi guys, welcome to lesson 5.4 part 2. The first type of factoring we're going to do today is sum and difference of cubes. This follows a formula, and this formula for the difference of two perfect cubes is just the cube root of the first minus the cube root of the second, and then the first one squared plus the first one times the second one plus the second one squared. So the first thing we should do when we look at a problem is cube root the a term and the b term and make a note of what those cube roots are, maybe right above each of the cube roots, and then we can work from the cube roots to square or to leave them the way they are. In the plus version, the sum of two cubes, it would be the a plus the b, a squared minus ab plus b squared. So they follow the same terms in the same order. The only difference is their signs. The difference of cubes starts with a minus and then is followed with a plus. The sum of cubes starts with a plus and follows with a minus. Both of them end with a plus. So some phrase that would work for memorizing the signs, after of course you memorize all the terms, is same, opposite, plus. Same sign, opposite sign of the problem, and always a plus sign in the last spot here. Okay, so this one is same sign, opposite sign for the next sign, and a plus sign for the last sign. Okay, so the first thing I'd like to do then is to cube root both these terms, and x cubed is just x cubed cube rooted is just x, and 27 cube rooted is 3, because 3 times 3 gets you 9, times 3 gets you 27. Okay, so then we need to follow the pattern for a binomial and a trinomial and fill in all these terms. So first we start with the a, which is x, then we do a b, which is a 3, and I'll come back through and I'll put in the signs. Then we have a squared, a squared is x squared. Then we have a times b, which is x times 3, which we could just write as 3x. Then we have b squared, which is 3 squared, which is 9. Then my signs are going to be same, opposite, plus. Okay, and that's how we factor that. So it's a bit of grunt work to work through that formula, but then you're done. The difference of cubes, let's cube root both terms. X, 2. There we have an A and a B, and let's go ahead and work through that right there. So we have just a binomial with just the plain AB, X, and 2. Then we have a trinomial with A squared, X squared, AB, which is 2X, and then B squared, which is 4. Then my signs, same, opposite, plus. Okay. Turn the page. Okay, so we're going to talk about factoring a trinomial. These trinomials now have a coefficient in the front spot. Okay, so what we want to do when there's a coefficient in the front is first try to GCF the coefficient out of that place. But in this case, there is no GCF for 3, 17, and 10 because 17 is prime. Okay, so what we're going to do is this. We're going to do this 4-step process. Do this double rainbow 3 times 10 and put the number off to the side over here on the other side of this line. 3 times 10 is 30. And then I'm looking for a pair of numbers that will multiply to 30 and add to 17. Okay, so what pair of numbers will multiply to 30 and add to 17? I think of 15 and 2, 10 and 3, 6 and 5. These are all pairs of numbers that will multiply to 30. Can any of them get a 17 by addition? 15 and 2 can. Okay, put the right signs on 15 and 2 to add to negative 17. We need negative 15 and negative 2. Okay, now we go back over here and we do some work. 3x squared comes down. Put these two terms with x's next. Minus 15x minus 2x. They should both look a lot like the 17x, and they should look like they subtract to 17. Because negative 15 minus 2 is negative 17. Bring down the 10. Okay, now you have 4 terms. and you're going to factor by grouping. The rest here should be familiar because we did factor by grouping the last time we were together. A 3 and a 5 have 3 and 15 have a 5 in common. X squared and x have an x in common. What is the result of these two values after 3x is divided off? X minus 5. Do the same thing here. What do 2 and 10 have in common? They have a 2 in common. You must GCF out that negative. And you have x minus 5, because negative 2 times negative 5 gets you positive 10. So both signs change when you GCF that negative. The negative 2x becomes a positive x. The positive 10 becomes a negative 5. And look, our two binomials are identical, so we can go ahead and put our two GCFs together in one binomial, and we write that repeated binomial once. Okay, and that's the four-step process. It starts with this double rainbow process and then this brainstorming of a pair of numbers that multiply to the third and add to the second. Okay, and then find that pair of numbers, put the right signs on them, and then put them here in the middle, just like that middle term with an x on each of them. First term and the fourth term just come down. Okay, so then number 19. All right, starting with the double rainbow, 4 times negative 3 is negative 12. What pair of numbers multiply to 12 and add to 4? I think of 4 and 3, that won't give you a 4, but what about 6 and 2? 6 and 2 can multiply to 12 and can add to 4, especially if it's negative 6, positive 2. That'll add to negative 4. Bring down the first term, 4y squared, bring these over to the middle space and make them both look like the middle term. Minus 6y plus 2y. Bring down the last term, minus 3. Okay. Next, underline, underline, and away you go. Out comes 2y. Left behind is 2y minus 3. Out comes a 1. This time it can be positive because the lead term is positive. 2y minus 3. But you have to take out something, so we have to take out a 1 multiplier. 1 times all this stuff doesn't change it. 2y plus 1 comes together. 2y minus 3 gets written once. Okay, so it's really the first couple steps over here that, and building this first line, that are new to us. Then after that, we're just factor by grouping, which should have a nice flow. Let's try this again. 5, 17, and 14, they're all, because of 17, they cannot be GCF'd. Okay, 5 times 14 is 70. Find two numbers that multiply to 70 and add to 17. We can think of 5 and 14, or 10 and 7. I think 10 and 7 will do it. Okay, if they're both positive, then that will get us positive 17. Bring down the first term, plus 10x plus 7x, and plus 14 comes down. Remember, your 10 and your 7 came from this brainstorming. Two numbers that will multiply to 70 and add to 17. Underline, underline, and factor by grouping, and away you go. 5x comes out, x plus 2. Positive 7 comes out, x plus 2. They're identical. Put your 5x plus 7 together, and your x plus 2 gets written once. Now, just because a trinomial has a coefficient in the front doesn't mean that you have to do the double rainbow method. If you can avoid it, try to. Notice how 4, 4, and 24 all have a 4 in common. So let's try to GCF first. W squared minus w minus 6. Wonderful. Keep that GCF in the front. Double bubble, because when there's a 1 in front, it's just one step to your answer. So you can just double bubble and ask yourself, for this pair of numbers, what multiplies to 6 and adds to 1? That could be 3 and 2. And what signs do you need? Negative 3 plus 2 will give you negative 1, and a negative times a positive will get you a negative. Okay, for this year, we're going to skip 22 to 25 in this year 2020 to 2021 school year. However, I will show it in the video just so that I can keep this video for future years. Okay, so what I'm going to do is I'm going to notice that this is just like factoring on steroids. So I'm going to have factoring in the numerator, factoring in the denominator, and then I will try to see if there's any like factors that can cancel. 3 and 1 can multiply to 3. Positive 3 minus 1 can add to 2. 4 and 3 can multiply to 12. Positive 4, positive 3 can add to 7. Then we cancel the like factor bubbles and we write down what's left. But I haven't so far this chapter had variables in the denominator, so I've got to be sure to make a little side statement that x cannot be equal to negative 4 and x cannot be equal to negative 3, because if x was negative 4 plus 4 is 0, then 0 times anything over here would be 0, and then we would have an undefined expression. So even though I'm not solving for x, I am making statements with x, and in that case, when you're just making simplified versions of an expression and there's variables in the denominator, then we have to make this exception for values that x cannot take on, okay? Because this right here is kind of implying that x takes on all values. All right, so let's do the same thing over again. Make a division sign, and then factor the top, factor the bottom. I'm doing the method of factoring where there's a 1 in front of a trinomial, and that means I just move right into my double bubble, my opening 2 parenthesis groupings, and asking myself for the pair of numbers that multiply to 6 and add to 1. And that could be 2 and 3. 2 and 3 will multiply to 6, especially if the 3 is negative, then they'll add to negative 1. A in the left sides. 5 and 2 can multiply to 10 and add to 7, plus plus. Now try to do any cancellations. I see a plus 2 and a plus 2 can cancel. I have a minus 3 over a plus 5 for my final answer, and I have to go to the denominator because I can't divide by 0. So a cannot be negative 5, a cannot be negative 2, and what I'm doing to find those is I'm taking each of those and I'm saying, hey, this expression cannot equal 0, and I'm solving. Okay, and so a plus 2 cannot equal 0, and I can just kind of mentally subtract that over and get a cannot equal negative 2. Okay, so that's how I get a cannot equal negative 5 and a cannot equal negative 2. All right, number 24. This is tricky because I have to do the double rainbow method here. 2 times 12 is 24, and best to just do it off to the side here where I have a little bit more logical room to work underneath. Okay, and 24, that could be 6 times 4 gets me 24. 12 times 2 gets me 24. 3 and 8. 3 and 8 can get me 11. So 2x squared plus 3x plus 8x plus 12. Bringing down, and using my 3 and my 8. Underline, underline. We have x, 2x plus 3. We have 4. 2x plus 3. My 2x plus 3s are identical. So x plus 4, 2x plus 3 is for the numerator. Now I still have to factor the denominator. 2x squared minus 13x minus 24. Draw a line, double rainbow. 2 times 24 is negative 48. 16 times 3 can get me 48 and can get me 13, especially if it's negative 16 and positive 3. So 2x squared minus 16x plus 3x minus 24. 2x comes out, x minus 8, plus 3 comes out, x minus 8. So we get 2x plus 3 and x minus 8. Okay, and that's the denominator. So now let's put this in the numerator. Okay, and let's put this in the denominator. Okay, just to put the factored forms back where they're going to go. All right, came from the numerator, so let's put it in the numerator. Came from the denominator, let's put it in the denominator. And then let's try to look for anything in common. So we get x plus 4 over x minus 8. I've got to take both these denominators and set them not equal to 0. I would add 8 over, x cannot equal 8. And 2x plus 3 cannot equal 0. Subtract 3. 2x cannot equal negative 3. Divide by 2. X cannot equal negative 3 halves. Okay, then over here, number 25, we have traditional factoring. Thank goodness. Okay, since there's a 1 in front, it's just one step to your answer. One step factoring. Okay, so let's multiply by 12. Sorry, what are two numbers that multiply to 12 and add to 7? That could be 4 and 3. Two negatives to subtract down to negative 7. In the denominator, put your x's on the left. 3 and 2 will multiply to 6, negative 3 plus 2. X minus 3's cancel. We have x minus 4 over x plus 2. You cannot do any more cancellations. You can only cancel an identical binomial with an identical binomial. It has to do with the fact that this is multiplication here, and that division and multiplication are opposite operations, and so then they can cancel. Okay, also take the denominators and set them not equal to 0 and solve. X cannot equal 3, x cannot equal negative 2. Okay. Okay, thanks for joining.